Part 1 of 13.1. A point P naught and a vector n define a plane. The normal vectors of parallel planes have the same direction. If a plane is given by this equation, then it has a normal vector that is just taken from the coefficients. Find an equation of the plane passing through these 3 points. An equation of a plane needs a point and a vector normal to the plane. For the point, I'll just take P, and then for the vector normal to the plane, I recognize that PQ is in the plane, PR is in the plane, and so their cross product will be orthogonal to the plane. So find PQ and PR. This is what I get. Now take their cross product. And find the determinant. And this is what I get for n. If we're going to find the equation of the plane, then what we can do is we just let S be a point on the plane. Then P naught S is a vector in the plane and is orthogonal to n. Set up this equation that's at the bottom here. And for P naught S, I get this vector. Take the dot product, and I get this. Clean it up. And let's look at the graph. There's a formula in your book if you prefer to use formulas. Let Q be the plane described by this equation. Find the point where Q intersects the x-axis. Since the point is on the x-axis, we have y and z both equal to 0. So we take the point x, 0, 0 and put it into the equation and then find what x would be. I get x equals 3. And so the point 3, 0, 0 is on the plane Q and on the x-axis. It's where the x-axis and the plane intersect. I could do the same thing with the y and z axes. What if instead I wanted to find a vector normal to the plane? As I mentioned earlier, all you need to do is read off the coefficients. And here is our normal vector. A section of the plane, and let's talk about something else. Two planes are parallel if their normal vectors are parallel, and they are orthogonal if their normal vectors are orthogonal. In a new example, find an equation of the line of intersection of the planes. How do we know that the planes intersect at a line? If you look at the coefficients, you can see that they're not parallel. To find an equation of a line, we need two things. We need a point. Any point will do. It just has to be on both planes. And we need to find a vector pointing in the direction of the line. We're going to use x, y, 0 for our point. So we're making the point, we're looking for the point where both planes intersect the xy plane. Where do both planes intersect the xy plane? Well, that would be a point that looks like xy 0. Put this into the two equations, and this is what I get. Solve these simultaneous equations. I get x equals 3, y equals 1. So the point 3, 1, 0 in the xy plane is on both Q and R. Let me back up. There we go. Okay, so the point 3, 1, 0 is on both planes. To find the vector describing the line, use the vector that is normal to both the normal vector of Q and the normal vector of R. So we're looking for the cross product of these two vectors that are normal to their planes. Set up my cross product, take the determinant. The line that intersects both planes contains the point 310 and is parallel to this vector. Find an equation of the line. To do that, we just use our knowledge of how to find an equation of a line, and this is what we get.